Let's make a stereoscopic animation now. This is where certain limitations come into play, and you have to figure out how to work around them. We're looking straight down onto the scene. The camera's placed at 9 o'clock, looking what's actually west, but because the picture's rotated, it looks like east on our screen. Normally in a 3D program, you would set up stereoscopic cameras by creating an animated move and then creating another camera, offsetting it a certain amount to create a stereo baseline and creating a parent-child relationship between the two cameras. Although 3D DVE does have the main scene and the alternate camera, there's no way to parent one to the other. You could copy the animation curves, but you can't really parent it. And this creates difficulties, along with the fact that this method of animation, looking at a target point, an interest point, versus being able to pan and tilt the camera, that doesn't help either. In this example, what I'm doing is I'm going to dolly the camera along the x-axis only. If I wanted to move the camera in a more oblique path, wanted to do a curved move or even go diagonally, that would not work, and you'll see why. It can work, but then you really have to calculate your keyframes so the left and the right eye camera work together. I'm going to switch back to the main scene camera. This is what we're looking at. I will click on the keyframe and click once again to delete all the keyframes. The only value that we're going to keyframe is the X position. So we'll click here to create a keyframe at this position. We'll go to the last keyframe and select the dolly tool, and we'll just dolly forward. So we'll call this our animation. The only thing I'm going to do is, again like I did before, select this curve and change it into a linear path. As you can see here on the left, X is the only value that's changing. And we can easily see that visually by looking down at the scene or looking from the front. I'll switch back to the scene camera and we'll exit out of here, go all the way up to the top. That's our animation. It's going to become the left eye animation. I'm going to right click on this and select Create Stereoscopic Container. And just so we know what this is, we'll type in left. Now I'm going to Control-C, copy this clip and paste it down here. So now we have the left and the right eye in a stereoscopic container. However, they're exactly the same, so nothing exciting will happen. Let's double click on the right eye, go inside the 3D DVE for the right eye, and now we have two options how to deal with this. I'll switch back to the alternate camera and take a look at the scene from the top. We can make this an equivalent of a parallel rig, with two cameras shooting in infinity parallel, which we'll have to adjust later, or we can simply offset one of the cameras and they will converge onto our target, which is in this case set at 0, 11, -3. So let's try the other method, and I'm not advocating one or the other. There's a lot of discussion about that, which method is better, and there are certain advantages and disadvantages with both. I will just say that with this method we'll create a little bit of keystoning distortion, but for our purposes that will be okay. I will offset the right eye camera by a large amount so you can see what's going on. Currently the value for the left eye is -3. Let's make the right eye 10, and you'll see the amount of the camera rotation around the target. This would create an incredibly poor stereoscopic picture. So, you know, guessing the right amount is sort of hard because these values really don't represent any real life values. You'll have to read up on how to make pleasing stereoscopic images, which is beyond the scope of this tutorial, but small values will definitely work better. So remember, the left eye was -3, and we'll make the right eye -1. Let's click on the scene camera. It looks like nothing's changed, but if you look at the anaglyph of these two images, you'll see the difference. So we'll get out of here. Here we have a little bit of difference between version 10.3 I'm using and 10.5 or above. In 10.3, if you right-click on the stereoscopic container and select stereoscopic properties, you will find out the output format selection here. In 10.5, this is in sequence properties. Instead of interleaved, we'll go to anaglyphic and take a look at this picture. Let's blow it up full screen. I will put my glasses on, and it looks the foreground looks pretty terrible. But if we fly over those first peaks, you'll probably get better. Yeah, that looks a lot better now. So I'm going to render this. Okay, good. Let's set up a loop. Yeah, as soon as we fly over the top, it's not too bad. Although some of these volumes behind seem pretty flat, but it works. One important thing to say here is that we're creating an animation where the angle of the toe-in of the cameras is being adjusted dynamically, which is something that is done on occasion with real cameras, but not all the time. So it's creating this unusual change of parallax in the distant mountains. As we're getting closer to our target, at which was, I believe, at 0, 12, 0, something like that, the cameras are more and more cross-eyed, so to speak. So that can create all kinds of problems. I said earlier that any camera moves that don't restrict themselves to a single axis are more difficult to deal with. Why are we limited to this Cartesian simple move? Here's a simple answer. Right now this camera is looking straight to the right. We're looking down at it. It's looking from 9 o'clock over to 3 o'clock. If I change the angle of the camera to maybe something like this, if you wanted to dolly this camera towards the interest point, that would be easy enough with the dolly tool, but creating the right eye camera would be more difficult because there is no parent-child relationship that can be created here. In this example, we would have to calculate the positions for the second camera at each keyframe for Z and X. If we were to move this on more axes, we would have to calculate those too. So for example, if we did a roll angle, we'd have to calculate that too, and it gets more and more complex from that point on. Here's to illustrate the point. If we were trying to animate only the roll of the cameras, and let's pretend these are camera bodies, we're looking straight down through the camera body, through the lens at a scene. I know these icons are not very representative, but I think once I move them, you'll see what I mean. So if we apply roll and copy and paste those animation curves to the other camera, we're going to get this, which is something that will create a horrible stereoscopic image if ever put together. Real camera rig really does this when it rolls. So the two cameras have to move in unison, not individually along their individual axes. And in order for us to achieve this, we would use roll, but in 3D DV, but we would also move each one of the cameras in Y and so forth. So it would get a lot more complex. We're at the end of our tutorial here. So as you've seen, the terrain modeling in 3D DV is very easy, and it's pretty fast to render. It's not incredibly sophisticated in terms of what you can do on the stereoscopic side, but it's a good tool to have. You never know when you may need something like this and you need to crank it out real fast without sending it to someone to do it in the graphics program. If you want to play with this, I have prepared a couple of these textures for you, which you can download from my website at hdhead.com, so you don't have to go through USGS or any of these other websites. But if you have time, download a demo of Global Mapper. You'll like it.